Hello everyone, my name is Renuka, Assistant Professor in Department of Electronics and Communication Engineering, Maharaja Institute of Technology, Mysore. In previous topics, we have dealt about what is an interrupt, the multi-level interrupts, what are the merits, demerits in multi-level interrupts, and what are the kind of communication, how communication plays a vital role in sending the characters or a block of data from one system to another. So these are some of the information that we had dealt in the previous chapter, correct? So we are going to start with a new topic, and it mainly comes on about the designing aspect of real-time systems. Okay, so it's called the design of real-time system, and it's a general introduction that we are going to study. Okay, the main objective of this chapter is to show how to approach the planning and design of a computer-based system, to illustrate the basic approach for the top-level design of real-time softwares, to illustrate some of the problems associated with real-time and multitasking softwares. So initially you have to, first primary thing is you have to know how to plan. First, the planning and scheduling is very important in any kind of computer-based system. What is the kind of methods that have to be developed in order to know what is the aspect that you are going to cover in the entire development of the system. If you take even a simple hot air blower, even if you want to develop that particular hardware, then what are the different kinds of softwares that are required? So you're going to learn about the different dimensions in which you're going to plan and then try to design and implement that particular system based or a computer based systems. Okay. So first let us know about the introduction of computer based systems. The real-time systems can be broadly classified into two main headers. One is called as a planning phase, other is called as a development phase. Okay. So planning plays a vital role. Based on your plan, what is the kind of performance that you are expecting out of a system is what you have to design, right? Designing and the performance. So first is the planning, and how should you plan, and based on that planning, how is the performance being evaluated? These two are the main headers in any of the, even if you take a simple computer based system or any real-time system, these are the basic two ways in which you are going to analyze. One is the planning, other is called as a development phase. So coming up to the planning phase, interpreting requirements to produce a detailed specification of a system to be developed and an outline plan of resources to carry out the development. So first of all, if you take any system, or let us not even think about real-time systems or any computer-based system. If you are planning to go out somewhere, what do? You just don't go, isn't it? You just plan where you have to go. What is the distance that you have to cover? How many people are you planning to take along with you for a trip, right? And if you're tired, what are the other resources that you require so that the trip becomes very interesting and adventurous, correct? So a planning is very important. Okay, you can't simply haphazardly, you can't go and encounter some problem and that might lead to some, it might be good or might not be. Okay, again it is based on a chance. You need to have a thought process in such a way that those imaginative thought has to be put on paper, okay, black and white. Plan to plan it in a very clear methodology so that you try to get those plan of action into a good performing hardware which can support with the software, right? This can be explained with the help of this diagram, what you see. You have a user need. A user need can be anything because it depends on the kind of need of a person or a group of person or an organization, correct? So user need has to be first written. What are the needs, what are the requirements? After writing down all the requirements, then you have to define that particular system. What do you call that system? What is that you are expecting of that system? So you have a need and then you have a system that needs to be developed in such a way that you actually comprehend whatever is being written as a need. Okay. With the definition of the system, what should you do? You should know what are the kind of supporting softwares that are required for that particular action, or if you want to develop a hardware, what kind of hardware that you have to go for? Is there any analysis process? So what kind of a software? So hardware in par with software has to be planned. okay, with the kind of system that you're going to define. Once you define it, you have to know what is the cost related to it, either the software or hardware, what is the amount that is that will be incurred during the designing and planning stage. It can just be an approximate value, it can't be an exact value. You have to approximately estimate what is the total cost involved in that process. Okay. Then you have requirement analysis. So based on the requirement and the definition, okay, then you're going to think what is the requirement that could be added as an advancement so that it can help based on the kind of specification that you have already described in the needs. Okay. Based on the needs, you're going to actually use the requirement analysis and try to get those specification outcomes. Okay. So these are the planning structure for both hardware and software, which should go hand in hand, so that for any kind of needs a user has predefined, that has to be implemented. So planning plays a vital role. So this is the simple structure how you have to go, you can go about and plan as to how you want to design your entire computer based system, okay, or a real time system. So I can just simply say that the outline of any resources are mainly categorized as how many people are you going to accommodate in this entire plan, how many people will be involved in getting the task done, and what is the time frame, okay, when you're going to start, when it's going to end, what is the time frame, okay. Then you have what are the kind of equipments that are required, okay, and then you have the cost. So because based on the exact cost, okay, on the PCB board and the components, you're going to list out what are the requirements, right. After that, you try to buy only one such set of PCB and the components. What will happen? During the wear and tear, there will be some components that you might actually, you'll not be able to use back again. Okay. So what you need to do, you have to buy again, right. So again cost is involved. So you have to take an approximation as to what is the amount of hardwares for the testing purpose user demand. Okay. So based on that, you can have the requirement based on the people, time, equipment and the cost. These are the 4 important headers wherein you have to think about during the planning process. Next you have what is called as decision regarding the hardware and the software. First you have to decide what kind of hardware has to be used for a particular software or for a different software, what kind of hardware can be accommodated, because it should go hand in hand. So you have to design, there could be some issues where certain hardware might not support the software, or certain software Microsoft can't be used for Android. So there will be some kind of conflict resolved in the initial stages during the planning process. Okay. So preliminary assessment of the type of computer. So what kind of computer are you looking for? Do you want just one single computer which has all the performance being analyzed in a single central placed computer, or you want a distributed type? Okay. Or can it be a hierarchical system? We have dealt what do you mean by hierarchical system, the 3 levels, right. So hierarchical system could be there, or you are planning for distributed, or it could be a single centralized computer. Okay. Based on that, you can also design initially. Then based on the outcome of this stage is a specification or the requirement. So what happens is the outcome of the initial planning is you have to have a perfect specification of all the hardware and the software which is implementable for the next stage. So the designing and specification has to be completed in the planning process itself. Okay. It is not exact, but it can be approximately done. Okay. Need not be complete or detailed, it can be unambiguous. So if I just say that it can be decided later, okay, for example, any system requirement, okay, if you're going to design. So you have certain specifications, okay, you're not planning it properly. So you'll just think that as and when the process would be dealt, let us think about it later. Okay, and then let us try to incorporate that after the planning during the performance analysis. Then what will happen when we have not planned, which is not there, you have not designed anything, or you have not taken any decision in the planning stage, and you're trying to implement those ideas during the performance stage, what will happen is there might be chances of you not getting the initial kind of processes that you have promised for yourself in that computer design that might not be, that might not support the entire task. Okay? So if it is not supporting by the time, it will be too late to get back to the initial stage or the planning stage. So you have to redo the planning process again. So instead of saying that let us decide it later, which is a real costlier and which will usually lead to a erroneous outcome, it is always better to have a mindset of let us plan for the most possible errors initially in the planning stage. What if this is the kind of processor that might require? What if this kind of processor could be used as a modular, so that whatever you're going to add on in future, probably it would be able to support. So these are some of the ideas that has to be dealt in the initial planning stage. Okay? So the simple example for this erroneous way of dealing with let us decide later, I can just give you an example here, the distribution of errors and the cost for the correcting errors. So if the first stage you're just writing down all the kind of requirements, the requirement, design, coding and other things are to be dealt under the initial stage. So the percentage of error that might encounter here after the planning stage will be 56%. If I consider as error as 56%, then designing part it might be just 27%. So without correcting, because you have already said that let us decide later. So this is the kind of outcome that is going to happen without your planning. So if you're trying to rectify the errors, okay, if you are adding on some processor, if you're adding on some other hardware units, or you're trying to change the entire software module, so what will happen? It might give you about 82% hike. So what is happening there? The cost which is required, okay, will be double, okay, to get this 82%. So initially, if you design a proper way, in the initial stages or the preliminary stages of your planning, then this kind of error can be minimized. So you can't just say that I can decide later. You have to decide initially with all the hindrances that might encounter during the development of any computer-based or a real-time systems. So next will be what is called as the developmental or a stage. Okay, what happens here in this developmental stages? Decompose a system into set of specific subtasks. So if I just say that you are allotted with a certain task that you have to complete this work by 5 o'clock or by 4 o'clock. Okay, so that entire complex structure can be broken down into a 1 hour task. Example is if you're preparing for some competitive exam, okay, you can't just have a 1 week holiday and prepare for the entire morning till evening, night, without sleeping. You can't ruin your health, isn't it? It's just for 1 week, you can't set a target for yourself for a competitive exam. What can you do? The entire complex task can be broken down into simpler modules. Okay, so you can just give about 1 hour, 2 hours initially every day without fail, so that you can reach towards your destination, right? So now the same way here, when you're taking a developmental phase, what is done? A decompose of the entire system, and you're setting into small sets of subtasks. Okay, so if you're able to develop those subtasks, all the subtasks leads to a final module. Okay, next, the preliminary design stage referred as a high level design stage. So whatever preliminary design that you're going to do, it is actually a high level, because you can't think about a low level designing and expect a higher output, right? So whatever you're going to plan, it has to be in such a way that you have to set a bar high, so that even if you're not able to reach there, at least you can have a mid, okay, level of design strategy for any of the computer based or a real time systems. The inputs to this stage are the high level specification, and the outputs are the global data structures and high level software specifications. So initially in developmental stage, what kind of software that you're going to use? It has to be high level software. What kind of hardware that is going to be used? It has to be higher end. Okay, and what kind of a board are you going to design? Is it a single? Are you using different kinds of memory, and what kind of buses are you going to use for the data transmission? It has to be quick. So you have to think about all the sophisticated, which is a global data structure, which should meet that global data structure. So extensive legions between hardware and the software designers is needed. So the importance of the compatibility between the hardware and the software plays a vital role, because if you want the hardware to run, you have to have a similar kind of software which are capable enough to drive these hardwares. Okay, so extensively it should go hand in hand. Okay, a need to revise the decision on the type of computer structure proposed. So there is a need for what kind of computers are you going to use in a system. In the sense, if you are just having a single processor, or you have a distributed, if you have a single task to be performed, you have one single computer and you have the operation being performed, right? Or you can have the same task being performed by multiple computers. Okay, which means you have multiple processors involved for multitasking purpose, right? So that revised decision that you have to think about, because if you don't decide that in this developmental stage, by the end of the product development, it will be very tough. Okay, so let us just take an example to understand this. A distributed system is to be used to decide on how many number of processors are used in communication, what kind of bandwidth is required, and what type of system are we talking about. Okay, so these are some of the examples. And control strategy need reviewing, considering control algorithms to be used. So you need to have a control strategy, because until unless you have a proper control system, the entire designing goes under veins, correct? So you need to have a proper designing and reviewing of the control system, and with the proper supporting algorithms could be used. End of the preliminary design, a review of both hardware and software design should be carried out. So during the developmental phase, you need to ensure that the preliminary design what you have done, it has to undergo the review stage. Review in the sense, if there is any changes that you want to incorporate during the performance, it has to be planned. So reviewing has to be done by more than one person. Okay, because the idea that I might have might not be similar to the other person, right? The kind of perspective each person will have will be different. They can view the same situation in a different way. So you need to have a review on having different kinds of hardware and supported software, so that you have the best developed computer based system. Okay. So detailed designing is usually broken down into two stages. One is called as a decomposition into modules and module internal design. So detailed designing is nothing but when I've told you that entire process can be broken into subtasks, right? So now if you take one single task, let us talk about designing a PCB board. For a simple PCB board, there are multiple PCB board to be designed, but we're going to take one single PCB board. So you're going to design and develop in that subtask itself, right? So that is the decomposition of the module. Then after that, you're going to have the module internal design has to be considered. So this is how we are going to actually break the entire huge task into simple subtask. So this can be explained with this diagram. So first is the preliminary design based on the kind of functional requirements that you're looking for. Then you have to have a detailed designing. Detailed designing is when you go for a detailed designing, when the entire task is broken down into simple subtasks, and each subtask will have the internal designing structure. It can be either software or the hardware. Okay. Then you have the code to be tested for each of these subtasks. Okay. And then for the hardware, you have to build a prototype boards which will support, so that these codes could run on those boards, right? Then you have, after doing that, you have to test each module. So it is not just one module now, you have multiple modules. So you are trying to integrate all the modules and trying to test, okay, for the validation. Okay, you are testing all the modules, okay, and this test combines all the software. Okay, first if you just say certain actuators will be performing certain work, then it is a monitoring. So you have multiple softwares that has to enable all this action, right? So you're trying to integrate all the software along with the hardware, okay, so that you get a proper combined module test for both hardware and the software. So when you do that, you have the integrated hardware software testing, and after that you have the validation. How do you do validation? Validation is when you compare with the standard, or you can have a multiple test which will be performed on the same system, and you can say that this is a kind of output that I am getting. This is expected and this is the output, and what is the error? So standard deviation could be measured. Okay, that is how you do validation. Okay, so this is a simple block diagram which talks about how you can actually have a development process which could be which is helpful in developing any system based or real-time systems. Then you have what is called as hardware designing. So when you are talking about hardware designing, okay, alone, what is that we are looking for? You are going to look for the first stage, which mainly talks about, are we having a separate board? So these are the questions that has to be put for yourself where you are trying to design initially during the planning stage, because now actually the planning stage has been completed. Now it is a performance, right? So now you have to think about one individual designing task. Okay, how do you do that? Are separate boards going to use for analog inputs and digital inputs, or all inputs are going to be concentrated on a board? So you have single input. Is it analog or a digital, or do you want both analog and digital to be combined and concentrated on a single board? That is the first question, based on the kind of requirements, right? Next, can the processor and memory be located on this on a different board, or do you want it on the same board? That is the next question. Okay, then what type of data bus that will be used so that the system can be configured, okay, whether you want it within or you want it out of the board. Okay, so based on this you are going to design your hardware. Next, coming to the software. Initially, first step that you can think about is a functional decomposition, which is also the top-down approach, which has been advocated by WRIT leads to the module subdivision based on a separation into functions. Each module performs a specific function. So here it is nothing about the functional decomposition. The entire structure could be broken down into simple subtasks or sub-modules, and you are going to work on individual modules, okay, and then you are going to combine all the modules and try to get the required output. That is called as a functional decomposition. So information hiding, or Parnas argued against the functional decomposition, and for module division based on hiding as much as possible of information used by module within the module. So it is like module within the module. So you have a task, the entire task, and then you have subtask, and within that subtask you have another subtask. Okay, so Parnas is one person who actually said that instead of going for functional decomposition, because we don't know, we are not sure about whether there will be a subdivision within the subtask. Okay, so he said that it is a module within the module has to be dealt. Okay, so then came the information hiding process. Then finally you have what is called as object oriented, or you have division of system based on data functions that can operate on a data. So object oriented based on what kind of data you are going to analyze, what you are going to predict, what you are going to monitor. So based on that kind of data, the operations will be performed. So this is the object oriented. They encapsulate the data, and the operation can be performed on the data. The operations of the objects are performed by sending a message to the object requesting the operation. So if there is any actuator that has to be set on, then what should you do? There should be a request which should be sent. Only then you have the actuators being on, right? So that becomes your object oriented. Then you have an object is an instance of classes. So it is an instance of classes. As a class defines a common structure that describes all members of class. So classes are organized hierarchically and subclasses inherit all the features of subordinate classes. So it's like a class defines a common structure that describes all members of class. So classes are organized hierarchically and subclasses inherit all features of superordinate class. So what do you mean by that? So you have a class, well, there is a structure within that class, okay, and that will be based on the main class, okay. So if you just imagine, the best example is inventory management, okay. You have the inventory management, okay, where you have multiple levels and you decide what are per day inventories could be maintained based on the main objective of whether you have the inventory or not. So based on the day-to-day activity, you can just consider whether the inventories in the store are there or not, right. So this is one such example of how object-oriented programming can be dealt, okay. Guidance on how to decide on boundary between functional modules or object modules, heuristic guiding module divisions. So you need to have a heuristic or you can just think about what kind of modular structure you want, so that it is the best way to analyze the best possible way you can get a very good performance of a system. So if you want a very good performance of a system, you have to have a heuristic approach, so that you can set the boundaries between the functional module as well as the object module. So guidance is required, right. So coupling and cohesive development by Constant and Jordan, maximizing of module cohesion and minimizing the coupling between the modules. So minimizing the coupling between the modules will definitely reduce the losses. So that will help in a better way of developing any of the system. Then partition to minimize the interfacing. So if you just have the partition between the interfacing, that has to be clearly used for the transformation of data, indicating a data flow diagram should be grouped so as to minimize the number of interconnection between the modules, because if you have more number of connections, there will be a huge amount of losses, correct. So our intention here is mainly to reduce the amount of losses, so for which the interconnection has to be minimum, okay. So in real time, if any of the standard kind of operating procedure and the real time operating procedure would be the same. The only difference here is you have to have a greater heuristic idea about the requirements and the planning process. So that can be subdivided into real-time hardware constraints, real-time software constraints, and the interactive. So these are the three different. One is the real-time, how the real-time operation is performed by a hardware for which a supporting software has been designed, and is it interactive. So these are the different headers in which a real-time has to be analyzed, okay. A simple specification, if you just look into the first unit that we dealt about the hot air blower. So assumption that the planning phase has been completed and the specification document has been prepared. So keeping hot air blower as one such example, we can understand how a real-time system could have been developed. What is the kind of methodology that was used for the performance of a hot air blower. Assuming here, when you are taking the example here, we are just assuming that there are already a specification list which has been prepared in a preliminary stage, and then you are just going to use for their performance. So in the specification list, what are the things that could be there? Okay, the first, as you can see here, hot air blower specification. First you have to think what kind of version you want a hot air blower to be. So in that you can have introduction, you can have as the system comprises of set of hot air blower arranged along with a conveyor belt. You have to be specific, because in a specification it has to be detailed analysis as to how you want the system to be designed, okay. So it is just a planning process. So with a specification, these are the listings. First is the introduction of what is the hot air blower. You have to formulate that. How many blowers do you want, okay. Several different configuration may be used within a minimum of 6 blowers and a maximum of 12. So here you are giving the specification. What is that you are looking for? Is it 6 or maximum of 12 could be used, Okay. Then what kind of plant interfacing that you can accommodate? The second here is the input from plant, the outlet temperature, analog signal which can range between 0 to 10 volts, and then you have corresponding to what kind of temperature. It could be about 20 degrees Celsius to about 64 degrees Celsius, whether you want it in a linear operation. Okay. So these are the technical specification for the interfacing. Okay, input plant interfacing. Then you want output plant interfacing. So first you had the introduction, then you have input. What is the kind of output? In the output, what do you have? You have heater control that which has set for heater control analog, which is about 0 to 10 volts, and corresponding to full heat which is about 0 volts, and no heat for minus 10 volts, and it is a linear relationship. So this will be your output plant. So you have introduction, input plant, requirement, and the output plant. So these are a PDA controller with a sampling interval of 40 milliseconds to be used, that is specification. The sampling interval may be changed but will not be less than 40 milliseconds. The controller parameters are to be expressed to the user in the standard analog form, that is proportional gain, integral action time, and the derivative action time. The set point is to be entered from the keyboard, and the controller parameters are to be varied or variable and are to be entered by the keyboard. So you have to specify what kind of controller are you using and how the input has been given. Is it to the keyboard, or is it just a manual, or do you want it to be automatic too? So you have to specify in the controllers. Then you have what is the operator communication. So where you have to have a panel which has been designed mainly to monitor the hot air blower. So the operator display is shown below. What should you have there? You have a set temperature. What is an actual temperature? What is the error? Because you need to set an alarm, right? Error. Then you have heater output. Then you have next will be the control setting, whether you want it as manual or it could be automated. So proportional gain, integral action, and derivative action. And obviously the date time is common in any of the monitoring system. What is the sampling? What is the interval in which you are going to check the monitoring? So this is all about the operation communication. The operator has to be communicated with this particular display unit. Next you have to go operator input. What kind of input an operator has to use? Numbers from the menu so that he can manually operate them. So in response to the number of entries, the present value of the item selected will be deleted from the display and the cursor positioned ready for the next input of a new value. So you have to be specific, automatically change when you are entering a manual data. So that has to be defined here. Okay. Then management information. One selection of item 6. So these are the 6, right? 6 items, operator menu, a management summary of performance of the plant over the previous 24 hours will be given. So it's just like you are taking a summary for a day. So 24 hours, one day summary will be maintained, because after entering how is the performance, it will give you all the details, right? So that summary has to be obtained for every 24 hours. So these are the 6 management information. Finally, you have the acceptance entry, wherein the seventh entry will give you the summary of the entire specification that was being monitored the entire day. Okay. So what should it provide? It should provide the average error, because you are scheduling for one single day, right? So average error in degrees Celsius for 24-hour period, average heat demands. Okay. Then for each 15-minute period, what is that you are expecting? Average demanded temperature, what is the average error, average heat demand, and date and time of the output. So these are this should be there in the summary. This is how you are going to list out the specification, okay, the entire specification of hot air blower during the planning stage. Okay. So this is the final will be the general information. There will be requirement for a maximum of 12 control units and a single display, and enter keyboard which can be switched between the units is adequate. And the general information has to be provided, wherein you will talk about how many control units can you accommodate and what kind of a display are you using. You have a keyboard entry and you have monitor to be displayed. So these are some of the specification of a document that would be required, okay, assuming that you have planned the entire system accurately. Now will be your designing part. I hope you have understood the basic concept, the introduction of the designing aspect of any hardware in any of the real-time system or any computer-based system. Thank you.